Hey everyone, we're looking at formula in this video. So the formula that we're being focusing on are mainly found in geometry, but we could easily take the techniques used here and extend them to other formula in science fields and in more mathematic algebra concepts. So we have prism, pyramid, and sphere. So what defines a prism, just so we're aware of this, a prism is any solid where the majority of the faces are rectangles. And then you'll have two bases, one on the top, one on the bottom. So capital B, we see within the formulas, capital B refers to the area of the base shape. Okay? And H does in fact represent the height of the figure. Height, in this sense, is the distance from one base to the other side. So a pyramid, similar concept. What defines a pyramid is the faces all meet at a single point. So there's actually a point within the shape. So here we have a 1/3 area of the base shape times the height. And sphere has a completely different formula. I want to say here, notice we're not seeing cylinder or cone in our formulas. That is because a cylinder can be viewed as a prism with just a base shape of a circle. And then a cone could be seen as a pyramid, since it meets at a point, with a base shape of a circle as well. So cones and cylinders will utilize the same formula. So we have these formulas as well for just area, triangle, rectangle, and trapezoid. We have surface area. So surface area is, if I wanted to wrap a sphere with like a piece of paper, that's the amount of paper I would need. So this formula tells us that. In the area of a circle, pi r squared. And we may occasionally need, this does not find us a volume or surface area, but we may occasionally need the Pythagorean theorem to find certain lengths. So let's take a moment to understand units, the different types of units we'll see. So I chose centimeters. I could use inches, miles, feet, millimeters. I just chose centimeters. So if I see centimeters, that signifies that the number it's attached to represents a length from one point to another point. Whereas when I see centimeters squared, that's actually representing an area. So think how much area this paper takes up of the table. That is centimeters squared. So that number would represent a space. And then centimeters cubed, that's more of a three-dimensional idea. So see this cube here. It has a third dimension to it, length, width, and a height. So understanding volume, we'll be using cubed, area we'll be seeing squared, and any other length would just be straight centimeters or inches, whatever you have. So let's look at our first example. I have a couple here for us. So we have this. First thing I notice is it does not meet at a point. My faces do not meet at a point, which tells me that this is going to be a prism. Okay? So the volume of a prism, just writing this down for us, is area of the base shape times the height. And in this, the base shape of this prism, if you look at it carefully enough, the base shape is not the bottom of the shape. It's not what's facing down. The base shape's going to be what is the least common shape in this figure. So we see the top's a rectangle, the side's a rectangle, that other side's going to be a rectangle, the bottom's going to be a rectangle. So the odd shape here is this trapezoid we see in front. So the area of a trapezoid is 1/2 multiplied by the sum of the two bases, base 1 plus base 2, multiplied by its height. And then we have to multiply by the height of the figure. Okay, so looking at this, we have 1/2. Base 1 we could say is 15 or 11, it doesn't matter. So 15. The other base of the trapezoid is 11. The height of the trapezoid is 3. And the height of the prism, as I said previously, the height of a prism is the distance from one base to the other base. So my front base to the back base, that's a distance of 18. So when we type all this into our calculator, oh, wait a minute, look at that. Isn't that some truth, right? Okay, so we have see, 15 plus 11. I'll do the 1/2 last. Times 3 times 18. And then we want to multiply this by a half, or we can divide by 2, same result, and we get 702. Now this, with our units, as we see on our diagram, is inches, and we need it to represent a volume to be inches cubed. Let's try another. So now, examining first, identifying really, what do we have? So in this, it meets at a point, so this is going to be a pyramid, or actually it's a cone if you want to get technical, but we're going to use the pyramid formula. So 1/3 area of the base shape times the height. So our base shape in this cone is a circle, and the area of a circle is pi times the radius squared, and times the height. All right, so we have 1/3 pi, which is 3.1415, and so on. The radius is 5, and we square that, and we multiply it by the height of 11. So using the calculator, again, I'll do the 1/3 last. So to get pi, we're going to hit second and then our little up symbol. So I'll put this here. So we hit second and then our little caret symbol for exponents. So I hit second to get pi, 5 squared and times 11. And now we have to multiply it by 1/3, or dividing it by 3 gets the same result. And since this is not a perfect value, meaning a perfect integer, we're going to say it's approximately, the volume is approximately 287, we'll say 98, and then our units are centimeters cubed. Not bad, just knowing what our base is and using the formula correctly. So working with another formula, this is probably the one that's most unique because, well, with a sphere, we only have one value to use. So let's say I want to find the volume of this sphere. So the volume of a sphere is 4/3 pi r cubed. Well, all I need to know is the radius. So I look at the diagram, see that our radius is 8. We get 8 cubed. So our graphing calculator would tell us, so we have pi, let's clear this. We have pi times 8. Now, cubed, there is a menu that will give us cubed, but I can use our exponent, place in 3, and I have to multiply now by 4/3, which gives us approximately 2,144.66, and our units would be feet and cubed, being volume. So what about the surface area of the sphere? The surface area. So with the formula being 4 pi r squared, take a moment now and work on finding the surface area, understanding what units we would place on the end of this. So go ahead and take a moment now, try it out. Okay, so how'd you do? Our radius is 8, so 8 squared, and plugging it into the calculator, we get 804.25 feet squared, since this is representing an area. All right, we have one last one to look at. So pyramids, probably the most difficult to draw. Takes a lot of practice to get these drawn correctly, but let's find the volume. So we have to first identify what is our base shape. So we're looking at the lengths along the base. We can say it's a rectangle, sure, but being that the length and width are the same, we have a base of a square. So that's going to be side times side. S is representing side, then our height. So we have 1/3, 6 multiplied by 6. But if we think about this, the 9 is not the actual height of our pyramid, the distance from the base to the top vertex. So we don't know what this height is. That's an issue. We can't go any further until we find that height. And this is, as I said earlier, where the Pythagorean theorem is very useful. So knowing that we have a right angle formed, we're able to use the Pythagorean theorem. So I'm going to draw, if you look carefully enough, we have a right triangle. Okay. and we have this length to be 9, and the whole side is 6, and since the center point is in the center of the square, we can say that this is half of 6, or just 3. We don't know this value, and that's what we're looking for. So the Pythagorean theorem would say, oh, we have 9 squared alone, since it's the hypotenuse, and we'll use h for the height, plus 3 squared, which gives us 81, and 9, and subtracting 9 gives us 72. So square rooting 72 is approximately, actually let's not figure out what the approximate value is. We'll say the height is this, okay? We're not gonna get the decimal for square root of 72 because we're gonna use this exactly. The less rounding we use, the better. So now, placing this value into our formula, it's 6 times 6, and we're gonna multiply that by square root of 72, okay? And so we get 6 times 6. We want to multiply this by the square root of 72. Let it evaluate that. We can divide it by 3, or I like to multiply by 1/3. You get to multiply by 1/3 actually in that first line. If you want to, you get the same result. We get 101.82 millimeters cubed. Okay, so again, the benefit of not finding, so the square root of 72, the benefit of not using square root of 72 is we would have to round here, which would make it less accurate as if compared to we would just use the square root of 72 in the problem. Okay, so more accurate. If I were to use the decimal, it would be less accurate. Okay, so good luck, guys, in practicing this. Formulas is just a matter of knowing what you have, placing it incorrectly. If you're missing something, knowing what you can do to find the missing length. Best of luck, and I'll see you in the next lesson.